All right. Cool. All right. There you go, guys. Let me know if you can see and hear everything coming through there. And you guys just might want to mute the actual thing so you don't hear me 6 times. Um, that actually sounds like a nightmare. I'm not gonna lie. More than one of me would not be fun. So you guys can see everything? Not yet. Alrighty. I I think so. Cool. Foster, by the way, this is primarily Oracle. I didn't know enough about SQL databases to try to give you best practices for making sure they're secure. But you can see it because it looks like you're on here. Awesome. Oh, let me fix that. All right, cool. Better? Oh, it was. It was definitely running. All right. And just waiting for Kayla. Oh, you're good. Mm-hmm. Cool. All right, so I think we're gonna get started. So first off, thank you guys. I appreciate your time. I'll keep it under 8 o'clock because I have dinner to eat. So we're doing basic database security and best practices for Oracle databases. If you'd like some MySQL databases covered in the future, let me know and I will do some research and I will create another lesson just like this for the SQL side of things. Aha, that's all right. So apparently MySQL comes with a script that'll do it for you. So ensuring a secure database is a whole different task in general than setting up a database. Setting up a database is pretty easy. You can probably do it in under an hour. Setting up a secure database is not an easy task, nor is it one and done type deal. You don't just set up a secure database and you're good to go forever. You have to constantly monitor and ensure that your database is staying secure and being set up the way you need it to protect the information on it. This is a presentation for best practices on Oracle databases. This is a very basic intro level presentation. If there's interest in the future, I will do a more advanced um, presentation with features like encryption, wallets, SSL authentication, and Oracle Advanced Security Tool support. So database security. Typically when we talk about databases and security and being hacked, we think large enterprise-wide hacks, Sony, Microsoft. But in reality, the best targets are small companies because they typically don't have the resources to set up a secure database. And they're forced to have to use their limited knowledge. So, and in our case with competitions, we deal with smaller, less secure databases, something like you would see in a small business application. So, usually, you're not the one setting up a brand new database. Databases are typically already set up. This is 2015. So, when you get handed a database, it'll be an existing database. Typically, there will be security holes in these existing databases for smaller companies or competition environments, such as the ones we do. Oracle databases, the first thing you want to look at is patches. Oracle databases are patched in quarters. They do October, July, I think, is one. They do it quarterly. Those are called CPUs, critical patch updates. And as of 11.2.04, they come in two separate files, one for the Java virtual machine and another one for the database itself. And starting with the CPU for October 2013, Java security essentials are included inside the CPU for the JVM. It's also very helpful to go to Oracle's website and look at the security alert and third-party patching bulletins to see what vulnerabilities you may be susceptible to and what steps you must take in mitigating them. You can see here in the bottom left corner, you have security alert and number description, and you can quite readily recognize some of the more recent ones that were very scary, such as Shell Shock and Heartbleed. I'm unfamiliar with Venom. I haven't heard of it. But this is what a security alert on Oracle's database would look like. All of those are links, and they give you steps to mitigating those vulnerabilities on your database. The third-party patching bulletins are more readily updated. They're not rolled out in a quarterly fashion, such as Oracle CPUs, and they're typically certified third parties that come up with these, and Oracle says, yes, these are functioning patches and help protect your database. So if you see something on the third-party patching bulletin that's a major vulnerability, it might be a good idea to patch with that patch. And typically the same steps are used to patch using third-party bulletin patches. And Robert says Venom dealt with bad floppy disk code in QEMU. So that's Venom. Next slide we have is what's next after patching. So patching would be your first logical step to help secure a database. But after all that's said and done, you're definitely still not a secure database. So what you're going to want to look at are user accounts and privileges and roles. User accounts that aren't used should be locked to ensure that you do not have anything they don't need access to or compromising. So if a user is never being used, you should lock it. So no matter what happens, that user cannot access the database. For users accessing database, you want to go with the principle of least privilege by starting at the lowest security levels and continuing to its subsequent levels. Can't enunciate that word. So your general guidelines for something like this would be installing only required software, activate only required services, give selective access to the database and OS. You typically don't want the same user to have access to both the database and OS. Limit users' access to only database objects they need to perform their tasks. So if they need to update, select, insert, view information, if they don't ever need to change any of the information on the database, they shouldn't have the ability to do so. So controlling information access. Controlling information access through users are done through what's called privileges and roles. So a user privilege is the right to run a particular type of SQL statement, the right to access an object that belongs to another user, etc., etc. These are individual permissions. So if you want to be able to insert in a particular table, which is where the data is stored on a database, you would have to give that user the privilege to insert in that table. A role, they're created by the users. There are Oracle default roles, but to have more security on your database, you typically want to create your own roles to help fine-tune what a user can do. And what these do is they group together privileges, so you can grant a user a role with a whole list of privileges, so you don't have to grant individual privileges for everything you need that user to do. So a role that you might do in a real-world application would be to create an HR employee role. And that would give the HR employee the ability to insert into a table, change that user's salary, view a table, so on and so forth, anything that the HR user might need to do on that database. So privileges, one of the most dangerous privileges any user can have is the system priv, which is the right to perform a particular action on any system object. default ones that you see are sysopper, sysdba, sys, and system. Those all have system privileges, and they can do anything they want on the database. So for example, the privilege to create a table space and to delete the rows of a table in a database are system privileges. So if you want to create a new table space, you have to be system. And something as short as truncate table can be used in a database. Quite literally, 3 words can destroy an entire database with system privileges. So you want to restrict these. To restrict user access to system privileges, you would want to secure the database data dictionary. The data dictionary is what the database uses to function, I guess you could say. The data dictionary is kind of the framework of what things are allowed to happen on the database. So to secure the data dictionary for system privileges, you want to set the 07 dictionary accessibility init parameter to false. So the 07 dictionary accessibility controls restrictions on system privileges. If the parameter is set to true, then access to objects in the sys schema is allowed. So if you set it to true, any user can access sys schema objects. So a malicious user with the anypriv could alter data dictionaries in the tables, such as the audit table, and delete their traces of what they've been doing. When I say anypriv, typically when you say grant any, you're allowed to grant any privileges or roles. So I give a user the grant any priv, and if the data dictionary accessibility is set to true, they can also access system schemas and objects, and they can grant things to those, which you don't want. So setting it to false, it gives you the ability to give a user like the insert any or create any privilege without worrying about them destroying a data dictionary. So inside a SQL Plus console, you can also do it through GUI interfaces. You would want to alter the system 07 dictionary accessibility to equal false, and you want to scope as an SP file. An SP file is an initialization file that the database references on startup. So data dictionary roles and privilege list descriptions. These are some of the big 3 that you want to keep an eye out for when you're looking at what your users are allowed to do system-wise. So select catalog grants this role to allow users to select privs on dictionary data views. That allows them to look at a data dictionary. Execute allows them to execute packages and procedures, and it will allow a user to execute any arbitrary code that they can load on the database. And you can obviously see how that would be bad. Delete catalog role. Grant this role to allow a user to delete records from the system audit tables, or any data dictionary in general. The sysaud and the sysfga log are 2 audit tables that the system uses to control the SQL statements that are ran. The sysaud is kind of an overarching audit table. The sysfga is a fine-grained audit table, and we'll speak about that in a couple slides here. These are not the only roles and privileges, but they are the most common and potentially harmful. So this is a very long script. It might be hard to read on the stream. I will send out the PowerPoint slides so you can take a closer look at it. But what this is doing is it's checking for system privileges on the entire database and the person who granted the system privileges to that user. So in this template here, we're looking for creating table, creating any table, creating views, altering tables such as deleting, dropping tables, and dropping views. Dropping tables and dropping views, if you're not familiar with database terminology, means to delete them. They're gone forever. And we're also looking at the users who granted the user, so we're kind of running up the ladder and seeing where it originated from and if that's a legitimate origin for that user privilege. Public privileges. So these are something all users would have when they're created. So you want to always revoke unnecessary privileges from public users. Public is granted execute privileges on the following packages. There is a list coming up, so bear with me. And in Oracle 11G, network access is controlled by an access control list, the ACL. This is an XML document. I have a reference to it in the references slide, but I didn't have time to cover it in this presentation as it's a little more in depth. So the first package is the UTL SMTP. This is a simple mail server for the database, and it permits arbitrary emails to be sent using the database. The ACL, the access control list, can be used to control which users have access to what machines, where emails can come from and be sent to. So let's say you want a user to only be able to send an email from his machine to his manager's machine. You could use the ACL to specify that is the only path those emails can take. Otherwise, it will get rejected. If that's not set up appropriately, this could be used to send spam emails with maybe a phishing link to collect user data, as you see there. That's one of the malicious uses for the SMTP server. We have the TCP, and this permits outgoing network connections to be established by the database server to any receiving or waiting network services, and arbitrary data can be sent between these channels. Again, the ACL controls this. The ACL controls all of these. So if you would like to implement these packages in a safe manner, your ACL has to be properly configured. HTTP allows the database to request and retrieve data via HTTP. Granting this package to a user may allow data to be sent via HTML forms to malicious websites. So it could allow you to export your database somewhere offsite, including all of the data, which is very bad. The file. This is file control for the OS level and at the database level. This is controlled on two levels, both OS and database. At the OS level, it's controlled with permissions on files and directories. And at database level, it's controlled by objects that allow access to specific file system directories. So your object permissions and privileges and roles would be the way you want to control this. This can be configured to allow for fine-grained security and very individualized access. Network access is denied by default, and ACL must be created to enable it. So if you'd like network access to file systems, you have to have an ACL created. So remote access. Remote access is probably not a good thing. You would want authentication if you have remote access. So to set up authentication, you would want remote OS authentication to be false. This means the database has to authenticate the user using something like LDAP. To set that up, you would want to run an alter system set remote OS authent false, and you want to put it inside the SP file, which is, again, what the database uses on startup to generate its rules and restrictions. Let's say it was enabled. What could happen? So we have the database user is authenticated externally. A remote system authenticates that user. The user logs into the database without further question from any computer. So if any of the above steps, if you look at them, the database does not have a say in who gets access to the database. If the remote machine says this person's okay to log on, then they're allowed to log on to the database. And that just seems kind of silly. So you wouldn't ask a stranger for permission to do something harmful to yourself, because you would say no in every case. But the stranger, they might say, yeah, go ahead, go do it. So you really want to make sure authentication is set up appropriately. And for all databases, Oracle side, before 11G, you want to make sure administrator authentication is set up, because as a default, it is not. After 11G, all administrators have to be authenticated on login using the database authentication. So to set that up on a database before 11G, you would want to make sure the initialization file also has a line for set remote admin authent equals false. So auditing. Auditing with regards to database refers to capturing and storing information about what is happening to the system. There are several types of auditing on Oracle databases. So there's mandatory auditing. This is auditing done by the server, and it has to be done. There's standard auditing. This needs to be configured using the audit trail parameter. on your database. So you want to set an audit trail, and you can create an XML document to configure what kind of auditing you would like to occur. To run that, you would open up a SQL Plus console and type in alter system set audit underscore trail, and you can specify what type of document you would like to use. I've seen people use text documents. I like XML documents due to their organizational structure, and you want to set it on the scope of the SB file again. You set new properties using the audit command. So audit set, and then you type in the property you'd like to run into that XML document. There's value-based auditing. This is very taxing on system resources. It captures every ounce of information that command is changed and the command itself. It's set up through the use of triggers, which initialize when a certain action happens on the database, such as a delete or an update or an insert. There is an example of a trigger later on in the slides, and I will run through that and explain how that is working on a line-by-line basis. There's fine-grained auditing, which is very powerful. It captures the whole SQL statement. It includes a serial number for each record, so you can quickly look it up using an index, and a statement number that links multiple audit entries to a single SQL statement. So when you run an audit, when you run a SQL statement, for standard auditing, if you run a SQL statement that collects 1,000 rows, you'll have 1,000 entries into your standard auditing table. With fine-grained auditing, you will have those 1,000 rows, but you will also link it back to a single statement instead of just a vague, cloudy, it came from this location. This is very specific, and it helps you figure out what was ran and why it was ran. So when you do that on fine-grained auditing, it allows you to look at what a user is looking at information-wise. So if you see some specific if you see some suspicious activity on a table that might have credit card information, you would want to look at what that user was doing and what he changed. And fine-grained auditing allows you to target it back to a single point of reference. Fine-grained auditing automatically focuses on auditing at the statement level, as I was saying. For example, a SQL statement that returns thousands of rows only generates one record, where the other methods may generate record per row, depending on the configuration. Standard auditing can be set up similar to fine-grained auditing, but with that you lose the serial number and the statement number. So take that into account if you choose to use standard, value, or fine-grained. So FGA and standard auditing are separate instances. To view both at once, the DBA common audit trail should be used. This combines and joins the tables so they can be viewed in one shot. This helps preserve system resources when you're viewing an audit table. System privilege auditing. This could have an adverse effect on the system due to the default session being done by access. So when you're running a system privilege audit and you're doing it by access, there are a lot of data entries into this. So to help mitigate this, you would want to combine it with a by session to generate one record. So a non-focused approach to this would be audit select any table where any crate trigger is used. A focus would be audit select any table by HR by session. So a session is an instance created between a user and a database. Object driv. Unlike system auditing, object is by session, and you must explicitly say by access to have each object recorded individually. One statement is generated per object unless you say by access. So the non-focused approach would be audit all on HR employees. A focused approach would be audit, update, and delete on HR employees by access. Can also be done using the failure of a command. So let's say you want to check if a user tried to do something on a table, such as update or delete, but it failed for some reason. Then you want to trace that back. You could do audit, update, delete on HR employees wherever not successful. And then it'll return all the results of an update that was not successful or a delete that was not successful. Deletes will always appear on your audit table because they affect everything. So here's an auditing code example. We have a value-based auditing. This is the one that collects all the user data and the SQL statement that was changed. So the trigger below, as it said before, value-based is dependent on triggers and how they're set up. So the trigger below focuses the auditing system on capturing changes to the salary column of the HR employees table, creating or replacing trigger. So the reason you want to say create or replace is because every time it's ran, if you have just the create, you'll error out and the trigger will never run. Replace trigger is just saying to the system, replace what was there and run it anyways. And you want to do it on system HR salary audit table. So the system user has an object called human resources salary audit. And this is just collecting a whole bunch of information from the HR salary table and putting it into a log table that the system owner has. And this runs back to the 07 Access Dictionary. So since this is a system schema object, you really want to make sure people don't have access to this table, and you want to ensure that that authentication is false. Otherwise, somebody can go in there with an update or delete any and delete the records of their changes to the HR salary and give themselves a very unfair promotion. So after update of salary, so this is saying after the salary table is updated on HR employees, so HR is the user, employees is the record, and this is a bunch of aliases, so referencing new is new, old is old. This is just saying new, I would want referencing the code below as new, and so on and so forth. And you want to do it for every row in the table. You can specify individual rows in a trigger, but there's no reason to because you might miss something. I prefer to do it for each row. And you want to begin your code. So if old.salary does not equal new salary, which is saying it's been updated and the salary doesn't match, then you want to check that and then insert it into the audit table. So insert into system.audit employees. Values is the syscontext. It's the user environment and the OS user and the system date. So it's just saying who did what, where it came from, and the time. And there's another syscontext function here, and it's saying who did what, where they came from, and what employee ID is it. Or a salary changed from, this is a row title, old salary to new salary. So it's stating in the log that the salary was, let's say, he made $32,000 and he got a raise and now he makes $35,000. It's saying salary changed from $32,000 to $35,000. You end your if and then you end your function. And the backslash is necessary to create a trigger. So don't forget that, otherwise things just might break. Fine-grained auditing. This is very, very powerful if implemented correctly. So you have a couple policies with fine-grained and audit criteria and audit actions, creating with the DBMS, which is the database manipulation, the fine-grained auditing, and adding a policy. So you want to add a policy name, the condition, the column, the object, the handler, and the status. These are things you want to address when creating a fine-grained auditing function. So over to the code, you're adding a policy, and you're calling the object schema HR. The object name is employees. So remember the HR.employees? That is the same thing here. And you're creating a policy name called audit employee salary. So your audit condition is where department ID is equal to 10. You want to check the salary column. You want to handle the schema, which is secure. The handler module, which it logs employee salary. You want to enable the fine-grained auditing, because if it's false, it'll never run. And you want to audit the select and update queries from an SQL statement. So anything where it's like select salary from HR employees, that would get logged. And the user would get logged, and the time, the location, all of that would be logged for that entry. So as I said before, deletes are always audited because all the columns are touched by a delete statement. So specific columns do not need to be identified. Merge statements are supported if the underlying insert and update statements meet the criteria defined in the FGA. To audit everything, just use a null statement. It'll run through everything. So this is the end of the presentation. If you like, I can go back and check out and explain some slides. These are some of the resources I used. The second one is the access control list. It's very simple. It's an XML document. Anybody can set this up using pre-made ones from Oracle's documentation website. And the top link is the CPU security alerts and third-party bulletin boards that Oracle uses to monitor vulnerabilities and patches. So yeah, open to questions. Really hoping you guys have some questions. So Robert asked some other resources that would be handy would to have a command that gets a list of current audits commands, and you can actually view that in the DBMS table. So if we go back, this policy, this actually stores the fine-grained auditing commands, and the procedures for standard auditing can be viewed in the XML document in plain text. So you can see how things are being audited, where they're being audited, and the commands behind them. Anything else? Any questions? All right, I don't think we have any questions. So I also have documentation on implementing encryption wallets and SSL. I will give that out at the end of the presentation. I'll combine it with some things, and I'll release that when I release the presentation again. Yeah, that's all we got. So thank you for watching, and if you have any questions, please feel free to email me, and I will help you out as best as possible. Thanks.